All right, I'm going to hit the lights. So we're talking about arithmetic series here. Good. All right, did you guys get your stat box? You got the title? We're good to go? All right, so this is pretty much review here. So an arithmetic series is the sum of the terms of an arithmetic sequence. That's what I was just talking about. So it's the sum of the terms in a finite arithmetic series. So we're not going on indefinitely. We're not adding up all the numbers in the universe. We're going to look at a certain part. So like I was saying earlier, maybe it's the first 50 terms or the first 10 terms or whatever it happens to be. All this stuff you already pretty much know. It kind of maybe new is the fact that S stands for sum, and we did talk about that right before winter break. N is the term number. When we talk about series, especially arithmetic series, because we're talking about a finite group of numbers here, N is going to stand actually for our last term number. So it'll stand for, if it's the first 50 terms, then we'll have 50 there. U sub 1 and the D here both stand for what we're used to them standing for. So U sub 1 is the first term, D is the common difference. U sub n, which we know is a term, we've been talking about it as a term here on out. In these particular problems, it does stand for the last term. So it's the last term that we're looking at. So if we are looking at the first 50 terms, it is the 50th term. It's the 50th number in the list because we're only looking at the first 50, or whatever that happens to be. Okay, so here's one of the two formulas. So we did just look at this in the formula packet. This is if you know the first term and you know the last term. If you know that the first term is whatever number, and you know the last term is whatever number that happens to be, you do also have to know how many terms there are, because you do need to know n. So you would fill in how many terms are there, the first term and the last term, and you can use this formula. So sometimes you don't know the last term, so you might not use this formula if you don't know the last term. Or if you don't know the term number, you might have to use one of the previous formulas we've learned to find the term number. So you kind of have to keep in mind that not every problem will go right for this formula. Some problems it will be better to use a different formula. So if you don't know the last term, then you can use this one. So you would have to know the first term and the common difference and the term number, and then you can use this formula. I did have some people that just really liked this one, and they kind of just stuck with this one the whole time. Keep in mind there's lots of parentheses going on here. So you have to figure out the term number. Goes in both of these spots. So the term number is in the formula twice. You have 2 times the first term, and then you also have to times that common difference. So a lot of parentheses going on here, so make sure we're careful with our order of operations as always. Okay. There might be, depending on like the different formulas, we know there might be different ways of using these formulas and coming to the solution. So if you think of something different, it doesn't mean you're necessarily wrong, but for these first few examples, I'm going to lead you through, how I would approach using those formulas. But again, you might find a different approach that works for you. Just make sure you are checking your answers, and if they're not working out, you're talking to me about it so you can get everything straightened out. Okay, I've been saying this over and over again, but again, you might need to use the sequence formulas to find information you need for the series formula. Like if you don't know the term number, you might have to go back and use that formula to find the term number. All right, so here is our first series. We're going to find the sum of 1/2 plus 3 plus 5.5 plus so on to 50 terms. So once you guys get this written down, a really good first step is to sort of figure out, okay, what do I already know? These are the things that I might use. I might not even need all of them, but these are the things that I might use for my two formulas. For one of the first formula doesn't use the common difference. The second formula doesn't use the last term. So we'll see what we've got here and kind of figure out what we should use there. So what is the first term? What's the first number in my series here? 1/2. Has anyone figured out the common difference? 2.5, okay. I like improper fractions, so I just changed mine to improper right away. What's the term number? How many terms are we looking at here? 50. So that would go in for n. Now, I don't know what the last term is, but I don't actually need to know because I can use the second formula, and I don't need that. I don't need that for this formula, so I'm going to use this one, which is n divided by 2, 2 times u sub 1, plus n minus 1 times the common difference. So I don't need u sub n to use that formula. I could find u sub n, and I could use the first formula if I wanted to. It would take 2 different steps, so that would not be incorrect, but I don't need this to use this formula. So then I'm just going to substitute all of those values in. So the sum of the first 50 terms is equal to 50 divided by 2, 2 times 1/2, plus 50 minus 1, times the common difference, which is 5/2. So I just plugged these three numbers in, but notice that the 50 was used twice. Are there any concerns about like why we use this formula or why we put something where we put it or anything? So this is where you just really want to be careful. Remember to follow your order of operations. So 50 divided by 2, that's not so bad. I've got 25. 2 times 1/2 is 1. 50 minus 1 is 49. Now I do need to multiply the 49 times 5/2 before I add this up. This isn't going to add up to 50. Remember, we have to multiply this first. That's kind of the most common mistake I end up seeing. So 49 times 5/2 is 122.5. So I have 25 times 123.5. So I end up with 3,087.5 for the sum of the first 50 terms. Now let's think about it. If this was before break and I gave you this, you would have to find actually the rest of the terms, the fourth term through the 50th term, and actually find them all and then add them all. Right? That would not be fun. So now we've got this formula, so that makes it a lot nicer to work with. Okay. So we're going to go for another one, and let's see where that takes us. So same directions, find the sum. And for this one, I've got 8 plus 10.5 plus 13 plus 15.5 plus a whole bunch of other stuff, and then plus 83. So we'll kind of look at everything we know. What's my first term? We got 8. What's the common difference? 2.5 again. That was just coincidental. Do I know how many terms I have? Like how many numbers are in this list? I don't know right now, which is kind of a problem because we need this no matter what formula. If I use the long formula or if I use the short formula, I need that. But I do know the last term, 83. And so, like I said, this is kind of a problem here because I need to know what n is before I can move on. So, we're going to try the short formula just so that you guys get experience with the short formula. We're not going to do that just yet. I'm just writing it on the board so we're ready. Because I need n. So before I can do this, and I would have to find n either way, both the long and the short formulas need n. But in order to find n, I'm going to have to use the formula that we originally learned, which was the use of n. Not going to use green, hang on. Use of n equals use of 1 plus n minus 1 times the common difference. So I'm going to have to use this first to find n, and then I can use my formula to find the sum, the series formula. So if I plug this stuff in here, I've got 83 equals 8 plus n minus 1 times 5 halves. So, I mean, you guys have done this before. We did this in section C. Make sure you use your solving equation skills to figure out what n is. So if I subtract 8 right away, I've got 75 equals n minus 1 times 5 halves. You can distribute your 5 halves. Does anyone have a different idea? If you don't, we can just distribute. And when you divide by 5 halves, it's timesing by 2/5. So you could times by 2/5 if you want. I think that makes makes it nicer, but if that's going to, yeah, makes it nicer? Okay, so you all heard me, you can distribute if you want to. I just subtracted the 8. Oh. Sorry, just kind of did a -8. So then, again, you can distribute, but just to kind of bring up a reminder, we could times by the reciprocal to cancel that out. So if I times 75 by 2/5, what'd you get? 30. Beautiful. So then I can add 1, and 31 equals n. So again, if you want to distribute, there's no harm in that. That's the way I did it originally, but kind of just bringing back some other math skills here. So now I've got my n, I've got my last term, I've got my first term. I can plug these 3 numbers in. So the sum of the first 31 terms is 31 divided by 2 times 8 plus 83. So now that I have n, I can plug that into the shorter formula. And again, if you really hate the short formula, if you just really want to work with 1, there's nothing wrong with using that longer one. If you use that longer one here, you will still get the same answer. And so, let's see, we've got 15.5 times 91, which is 1,410.5. Okay, what do you guys think so far about this stuff? To me, I noticed that like the hardest thing is deciding like which formula you want to use, and then like realizing like, oh, I have to do some extra work before I can use either formula because I don't know what the n is. All right, I think just one last example for us that I have planned, and it's back. Sigma is back. So we'll talk about how we can actually use our new formulas and work with sigma and kind of review what's going on with sigma as well here. So one big clue here also is it says arithmetic, so I know it's arithmetic, so I don't have to like get a bunch of terms and test that it's arithmetic, right? We've talked about that a little bit before break, if that's possible. So one thing I can do, it's just like I've been doing. I don't know these things yet, but I can find the first term. I can find the term number. I could, oops, if I do it in the same order, I did common difference first before. I could find the term number, and I could find the last term. In fact, I should actually already know the term number. How many terms are we adding up here? 15. Remember, this is like how many terms we're adding up. So this is actually n. So I already know that n is 15. I don't know the common difference yet. I don't know the first term. I don't know the last term. But it's really not that crazy to find them. Because for the first term, I have to put 1 in for k here. So to find the first term, that's just when I plug 1 in here. So 1 minus 50 is negative 49. That's my first term. Well, if I'm going to the first 15 terms, I can find the 15th term by plugging in 15 for k. So I can do 15 minus 50, which is negative 35. And so since I'm only going to the 15th terms, that's actually my used up n. My last term in the list, the 15th term is the last term, because we're stopping after there, is negative 35. Now, I don't don't know the common difference, but I don't even need to know the common difference because I can use the short formula, which is just n divided by 2, and then the first term plus the last term. Now, if you were one of those people that really like the long formula, you'll want to find the second term and calculate the common difference, but we don't really need to. The sum of my first 15 terms, I can do 15 over 2, and then negative 49 plus negative 35. Let me finish this up and then I'll quickly go over that, okay? So 15 divided by 2 is 7.5, negative 49 plus negative 35 is negative 84. And when I multiply those, I get negative 630. So if I wanted to, add those first 15 terms, I would end up with negative 630. Now, like I said, if you're really into the long formula, you can find the second term by plugging into 2 into here. So 2 minus 50 is negative 48. So remember that you can take a term and minus the term before it. So if I have negative 48 minus negative 49, what do I end up with? So like if my second term is negative 48, that means my list, I don't know where I could write this, is I've got negative 49, and then I've got negative 48. So what's the difference between these two? 1, so that means the common difference is 1. So if you wanted to do the long formula, you could just find the next one, so you just plug in 2, you would plug in 1 and 2, do that subtraction, or if it helps you to do the list, okay, adding 1 each time. And then you could plug in this, and this into the long formula. But so you would just have to take, instead of doing this step here, you would do 1 and 2, and then subtract out for the common difference. Okay. That is it for our examples. I don't know, what's one thing that you guys feel like you learned from today's lesson? Or like, what's the first thing you want to see if you turn back to this page? You know. The formulas? Definitely important. Okay, so here is the assignment for 6F. As you guys are jotting this down, tomorrow is 3G, and there is a part 1 and a part 2, but we'll be covering all of the notes tomorrow. 6G? Yeah, what did I say? 3G? Yeah, well, 3G. Like cell phones? No? Oh, okay. Like, I'm sure that's why that happened, but yeah, so for 6G, we're going to do all of the notes tomorrow, and I'm going to clearly tell you this is G1 and this is G2, but just to kind of give you a heads up that we are doing all of G tomorrow, so we got 2 review days, and the test is on Friday.